Hello children, today we are going to see here matrices chapter. In this section we define a matrix and its order and various types of matrices. Okay, first of all, what is the definition and what is the actual, we define the matrix, how we are going to define a matrix. Okay, what is matrix? An order matrix is nothing but, first one we have to know what is matrix. First of all, an order rectangular array of elements is called matrix. Okay, ordered rectangular we have to write in the form of rectangular form, array of elements, okay, is called matrix. Okay, an ordered rectangular array of elements is called matrix. Okay, now this is simply we call it as matrix. And what is the order of matrix? Okay, what is an order? How we will write the order of matrix? First of all, for following, for example, we define the matrix, we denote matrices by capital letters. Okay, how you will define? By capital letters we have to define. For example, A, B, C, so on, like this we have to take. Okay, some example we have to take here. Here A is equal to, what is this? It is a matrix, and here square brackets we have to define, and 1 2 3 4 5 6. This is example for a simple matrices, simple matrix. This is what this is a rectangular and array of matrix. Okay, some elements which are numbers. And this is also B is, I am taking another matrix, that is 1 2 3 4. Okay, this is also a matrix. Okay, in this how many rows are there? This is horizontal is called row, and this one is vertical is column. We said it as column, and this one is row. Horizontal line is called rows and vertical line is called column. Okay, this is first column and second column, and this one is third column, and this one is first row and second row. Okay, 2 rows and 3 columns are there. Okay, in this how many rows are there? This one first row, this one is first row, and this one is second row. This one is first column, this one is second column. In these 3 columns are there 2 rows and 3 columns. Okay, in these 2 rows and 2 columns are there. So we define like this. One A is a matrix and B is also matrix with 2 rows and 3 columns here, 2 rows and 2 columns here. So in this above example, we have horizontal lines of elements are said to be the rows, and vertical lines of elements are said to be columns of the matrix. The A has how many? 2 rows and 3 columns, and B has 2 rows and 2 columns. Okay, now what is order? What is order of matrix? Okay, simply very easy to define the order of matrix if you know the matrix formation. Okay, a matrix having m rows and n columns is said to be order of matrix. Order m by n. When m rows and n columns in the matrix, then is said to be order m by n, where real numbers m cross we said as, read it as how, m cross n or m by n. Okay, now what here? A matrix having m rows and n columns is said to be of order m by n. Okay, whenever we have m rows and n columns are there, then order is m by n we said. Okay, and we read it as m cross n. Okay, this is m cross n or m by n. See here, we read it as m cross n or m by n. Okay, order is m cross n. Okay, for example, for this example, by example only we can understand this order. Okay, now see here, in this A is the order of how much? 2 rows and 3 columns. How you will write? A is equal to, A is a matrix. Okay, how many rows? 3 columns and 2 rows are there. M rows, m and n. So write it as m, how many rows? 2, and n means columns, 3 columns. So this is order of 2 by n. Order of A is how much? 2 by m. And B, for example, B is a matrix. Now here above example we are taken, no, this one B, how many rows are there? 2 rows. And how many columns? 2 columns. Now order can be written in the form of m by n, means m is in the form of rows, that is 2, by n is 2 columns. Then 2 by order of B matrix is 2 by 2. Okay, like this we have to define the order of a matrix. Okay, this can be also a matrix having a matrix having m rows and n columns is represented as follows. That is, A is equal to how we will define when m rows and n columns are there. Simply we have to represent a matrix like this. A matrix is taken, A11, A12, array of elements are there, A1j, so on, A1n. Okay, nth element is there, and A21 and A22, so on, A2j. Okay, middle term is j term and last term is nth term, so A2n is there. Now like this we have AI1, ith term is there, AI2, and so on, Aij, and like this we goes up to AIN, and last term that is AM1, so on, AM2, and like this AMJ and AMN. Okay, this is the formation whenever having m rows and n columns. A matrix can be represented in this form. Okay, now in this above matrix, every element is specified by its position in terms of rows and columns which the element is present. The first and second suffix of an element indicates respectively the row and the column in which the element is present. Okay, for example, A23 is there, then this one A23, here it will comes, is the element present in the A23 means what? This one is second row and this one is third column. Okay, this is in the second row and in the third column. This one second row, A23 means here, A23 means second row and third column. Okay, now A21 means this is second row. How we will identify? Specified location is there, specified position is there, first column, this one, 1 means first column and 2 means m position, that is second row. Okay, where it will, A21 means second row and first column. Like this we have to identify the specified position of the terms of rows and columns. Okay, in compact form of the above matrix, in compact form of above matrix can be written as is denoted by A is a matrix and elements are in small a and ij, where m cross n is the order. Okay, now where 1 less than or equal to I less than or equal to m, and another one j 1 less than or equal to j less than or equal to n. So I is up to m and j is up to n, mn. Okay. Throughout this we have generally considered matrices of m by n, where m and n are rows and columns. Okay. Now what are the types of matrices? Different types of matrices are there. We have, based on these types, we have different problems also there. Very easy chapter to understand and do the problems. Okay, we have 7 most important types of matrices are there. Square matrices, square matrix. Second one, diagonal matrix. Third one is scalar matrix. Fourth one is unit matrix. Okay, now fifth one, coming to fifth one, null matrix. Sixth one is row and column matrix, row matrix and column matrix. Okay, now seventh one is triangular matrices, triangular matrices. Okay, now one by one we will go to see here what is square matrix, diagonal matrix and all the above. Okay, 7 matrix types are there. Now first of all we are going to do now square matrix. How we will denote the square matrix and how to define the square matrix we will see here. Okay, now a matrix is in which the number of rows is equal to number of columns. In a matrix it is saying that number of rows is equal to number of columns. Okay, then it is said to be a square matrix. That is, A is equal to aij matrix with m by n as a form of order is a square matrix, is said to be a square matrix. Okay, now when it is said to be a square matrix, if m equal to n. Okay, number of elements in row is equal to number of columns elements. Okay, so both elements in these rows and columns must be equal. In this case we say that A is a square matrix of order m equal to n. For example, here 2 is a square mat. Here I am taking here 1 minus 1 0 4 is a square matrix. Okay, square matrix. Okay, here see, this is how many rows? 2 rows. Okay, this one and this one is 2 rows. We have 2 rows. M is 2 and columns also 2. So 2 by 2. Here m equal to 2 and n equal to 2. Therefore this matrix is a square matrix. Okay, and another one is, see here, another 1 0 1 2 3 4 5 6 7 I am taking for example. This is another matrix example, and for this also how many rows are there? 1 2 3 rows. Okay, by 1 2 3 vertical lines are 1 2 3, 3 columns are there. So therefore m equal to 3 and n equal to 3. therefore m equal to n, so equal to 3. So rows, number of rows and number of columns are equal. So this is the example of square of order 3, and here is of order is 2 here and order is 3 here. Okay, like this is the square matrix. Okay children, now what is diagonal matrix? Diagonal matrix: if each non-diagonal element of a matrix, if each non-diagonal element of a square matrix is equal to 0. Non-diagonal elements, non-diagonal means I will show here, is equal to 0. They are always 0. Then that is said to be a diagonal matrix. Okay, for example, see here. Example is 0, 0, 0, 2. And this one is a diagonal, and non-diagonal means this one and this one. So these are both are equal to 0. Then this is diagonal matrix. Okay. Now another example is 2, 1, 0, 2, 0, 0, minus 1, 3, and here 0, 0, 0. This is the diagonal position, and non-diagonal means this one, this one, this one, and this one, this one, this one. So these three and these three are zeros. So this is also diagonal matrix. Okay. Like this, in every square matrix, if non-diagonal elements in a square matrix of a square matrix is equal to 0, then this is diagonal matrix. Okay. Now let us see third one, that is scalar matrix. What is scalar matrix? If each non, I think you understand this chapter. You have earlier you have learned this matrix chapter, so that it is very easy to understand the what are the basic types of matrices. Okay, if each non-diagonal element of a square matrix is 0 and all diagonal elements are equal to each other. So see here, this is another type of matrix, that is, if each diagonal elements of a square matrix is 0, means this is what diagonal matrix. And in this scalar matrix, another option is, and all diagonal elements must be equal to each other. So for example, I am showing here. For example, it is a matrix 2, 0, 0, 2, 2 by 2 matrix, square matrix, and this one is the diagonal elements, that is 0, 0, this is 2 by 2, order is 2, and non-diagonal elements is this one and this one is equal to 0. Then this is also called as diagonal matrix. And for scalar matrix, we have another point, that is diagonal elements must be equal to each other. So 2 and 2 are same, so they are equal to each other. This matrix is called scalar matrix. Okay. Now another example is, for example, 1, 0, 0, 0, 1, 0, 0, 0, 1. What is this? This is diagonal matrix, diagonal elements 1, 1, 1. All elements are equal to each other, and non-diagonal elements are equal to 0. So this is also scalar matrix. Okay. Like this we have to find the scalar matrix. Now fourth one is unit matrix. Okay, unit matrix is also called as what? Identity. identity matrix. Okay, unit matrix is also called as identity matrix if each elements of non-diagonal elements of a square matrix is 1 and diagonal elements is 0 and diagonal elements are equal to 1 See here children, very easy to understand every matrix. Then this type of matrix is called unit matrix or identity matrix. Identity means 1, unit means 1. So we can easily remember this matrix. Okay, for example here, or each non-diagonal elements of a square matrix is 0 and diagonal matrix are equal to 1. So first 1 1 1 is the diagonal matrix elements and this must be equal to 1, not minus 1 or any other element, only must be equal to 1. And non-diagonal elements means this type, these elements and these elements are 0, must be equal to 0 and must be equal to 1. So then only we can say it as unit or identity matrix. Now another one is fifth one, that is null matrix. What is null matrix or zero matrix? We can also say it as zero matrix if each element of matrix is 0. Okay, then that matrix is called null or zero matrix. We can also define that 0 O m by n. Okay, simply by O, that is O equal to 0 0 0 0 like this, or 0 0 0 0 0 0. This is also another example. Both are null matrix, all elements are zeros. Okay, now sixth matrix, that is row matrix or and column matrix. What is this row and column matrix? Children, in this row matrix or and column matrix, a matrix is only matrix having only one row is row matrix, and matrix having only one column, then it is column matrix. Okay, for example, see here, in this we have 1 2 3, this is only one row, then it is row matrix. And if for example here 1 2 3, in this only one column vertical line is there, then this is how much? 3. This is 2 3 rows and one column order is, and this one is one row and 3 columns are there, then this is one vertical line, that is column matrix. Okay, then this type of matrices are called row matrix and column matrix. Okay, now another one is seventh one, that is triangular matrix. I think you are going to be very easy to understand this video. Types of matrices, what is matrix, okay, order of matrix. So watch complete video so that you can understand the different types of matrices in this video. So like, share and subscribe my videos. A triangular matrix, a square matrix is said to be upper triangular. Okay, triangular if Aij is equal to 0 for all I greater than j. Okay, and lower triangular matrix if what Aij is equal to 0 for every I less than j. Okay, triangular matrices we have upper triangular and lower triangular matrices. For example, I will show here, you can understand easily by example only. Okay, 2 minus 4 0 0 3 minus 2 and 0 0 1 here, and 3 minus 1 1 0 4 minus 3 1 0 4 are upper triangular matrices. Okay, because here last three elements here in triangle shape, and this triangle is in triangular form. This one is upper triangular. Okay, below are 0, small triangle is zeros. Okay, this one is upper triangular elements, so this is upper triangle. And here also upper triangular elements are not 0, and below one is 0, so this also a upper triangular. Another example in this also, lower triangular means we have to write lower elements 1 0 2, and here above small triangle, that is zeros. Okay, this one is 0 here, so below numbers are elements that are not equal to 0, and here also 1 2 1 0, this is also lower triangular matrix. This is upper triangular matrix. Here see, here this one is triangle, all elements are lower triangle, above one is 0. In this also these are above are zeros, but these three, this long triangle is elements, then these are below elements, this is forming a triangular, so this is lower triangular matrix. Like this we have to identify the upper triangular matrix and lower triangular matrix. Okay, aij is equal to 0 when I greater than 0 is upper triangular, aij equal to 0 when I less than j, so that is lower triangular matrix. So like, share and subscribe my channel, and comment me how this video is useful for you. Okay, if any doubts, please comment me in my comment section. Thank you for watching my video. Watch completely so that you can understand each definition and each matrix types. Okay, thank you for watching.